living in Frankfurt and working in Berlin. Could this ever be feasible? Commuting between Frankfurt and Berlin every day seems crazy, with current commuting times of roughly 4 hours. To make such a lifestyle convenient, travel times have to be cut down to 30 minutes. At a distance of 430 kilometers, traveling with the speed of sound is necessary to do the trip in half an hour. Is this feasible? The two biggest problems with conventional transportation are friction and air resistance. While friction is almost constant regardless of speed, air resistance increases by speed squared. To keep a vehicle at high velocities, braking due to air resistance has to be cancelled out continuously. The result is a high energy demand to keep traveling at the same speed. Eliminating air resistance and friction brings a huge advantage. Once the vehicle is accelerated, traveling at a constant speed does not consume extra energy. The solution to eliminate friction already exists in form of magnetic levitation trains. These trains work by creating a magnetic field which levitates the vehicle a few millimeters above the track. This means no friction. Magnetic levitation trains failed. This was because of extreme air resistance the trains encountered at high speeds. Mitigating air resistance can only be effectively done by removing the air. Hyperloop does exactly this by putting a magnetic levitation train inside a vacuum tube.
Most technologies come with two costs: the initial construction expenses and the operating costs. Hyperloop has a very high construction cost, but very low operating costs. Causes for the high construction costs are long tracks of several hundred kilometers. There is no existing infrastructure, so everything has to be built new. Both the magnetic levitation tracks and the vacuum tube are expensive. Tracks have to be built on posts or underground. Operating costs, on the other hand, are very low. Inside the vacuum tube, there is no air resistance, and because of the magnetic levitation, no friction. This means nothing is slowing down the capsules, and therefore no engine has to be kept running. This means no energy is necessary to keep traveling. The only energy expended in a Hyperloop system are the costs of running the vacuum pumps and the initial acceleration of the capsule. The energy for accelerating can even be recuperated when braking at a destination. This is possible because the process to accelerate the capsule is the same as decelerating, but just the other way around. The vehicle loses speed and the energy can be harnessed. The energy of running pumps can be kept at a minimum if the tubes are sealed properly. Because of the low energy demands, the environmental footprint of Hyperloop is very small. Therefore, the energy can easily be produced by renewable energy sources. Even solar panels on top of the tubes would be enough to power the system. Looking at emissions per kilometer, Hyperloop is therefore by far the most efficient form of traveling, even compared to electric cars. A Hyperloop system has two safety vulnerabilities. The main weakness point of Hyperloop tracks are the posts on which it is built. If they break due to natural forces or because of an attack, capsules up to 1 kilometer ahead would be endangered. Because of the high velocities, up to 8G braking is needed to stop within a kilometer. The technology is there to brake even harder, but higher forces would likely harm the passengers. Even though this sounds scary, breaking of a Hyperloop post is even less likely than the collapse of a normal bridge. The other vulnerability lies in cabin pressure loss. In this case, passengers would be exposed to a vacuum just like in space. The part of the track where the capsule is must be filled with air quickly and be disconnected from the rest of the track. This problem is comparable to pressure loss in airplanes and therefore very rare and manageable. The two companies actively working towards a commercial version are Hyperloop TT and Hyperloop One. The European company Hyperloop TT is currently building a test track in Toulouse, France. They plan to build their first commercial track in Q3 2019. As cost is a major factor in developing and running Hyperloop, it should not come as a surprise that it will connect Abu Dhabi and Al Ain. Hyperloop One launched a competition to determine where their first tracks should be built. Germany took part in the competition with a track connecting Berlin and Hamburg, but lost because of regulatory difficulties. One difficulty is that this track alone would run through 4 different states. Another problem is where to build the track, as it is difficult by connecting land between the cities. Therefore, one idea is to build the tracks above the Autobahn, which already belongs to the federal government. The track in Europe which won the competition was a track connecting Edinburgh and London. One reason why a track in the UK makes sense is because the major cities all are on one line. Furthermore, London is highly overpopulated, and connecting smaller communities could help to take pressure off the housing market. Commuting times within one city are often up to 1 hour. With the high travel velocities of Hyperloop, it could become reality that a trip within one city takes longer than getting to another one. This has the power to change the entire demographics of Europe. The continent is already very connected, and it is not uncommon that people visit another country multiple times a week. Hyperloop could make the perceived distances between cities very short and make traveling within Europe very fast and convenient. This helps business and tourism. Also, countries in Europe will get more connected socially and culturally, which probably has a very positive effect on cooperation within the Union. A Hyperloop connection also has an impact on the surrounding countryside. Traditionally, remote areas were not attractive to live in because of the high distances to potential jobs and infrastructure. By building small stops in smaller cities, they can, as far as travel time goes, get closer to downtown and then surrounding suburbs. This has advantages for both people in the big cities and the remote areas. People from cities could live in the countryside, which has better and cheaper living. People from the countryside also get major advantages, like better access to healthcare and education, an extended job market, and the ability to participate in social activities.
One day, a Hyperloop track may even be built across the North Pole to connect Europe with North America. Such a connection might be run with speeds up to Mach 5. This could shorten the travel time to 4 hours. But let's face it, such a project won't be completed in the next decades. Until then, maybe supersonic aircrafts could make traveling between the continents more convenient. Boom is a new aircraft manufacturer which wants to bring supersonic aircrafts to the commercial aviation market. Supersonic aircrafts already existed 20 years ago. Why did we stop building them? Supersonic aircrafts had 2 major problems. After multiple incidents, and especially after the Air Force crash in 2000, many people saw the Concorde as being too dangerous. This led to a decline in prestige and therefore to less tickets sold. As bad as this was, the real problem were high ticket prices. A flight from Paris to New York with the Concorde cost $10,000. For comparison, a conventional first-class ticket could be had for $6,000, and an economy class ticket was available for around $1,000. Even with such high ticket prices, the operation of supersonic jets was not profitable. The ticket prices were a direct result of high operating costs. As seen before, high speeds lead to exponentially higher air resistance. Claims vary widely, but the fuel consumption for the Concorde was around 5 to 10 times as high as for conventional aircraft. Initial construction of the Concorde happened 30 years ago. How can Boom use the advancements since then to reduce those problems? The biggest advantage that Boom has are new materials and new manufacturing processes. New materials like carbon fiber make it easier to build light and therefore more efficient airplanes. Furthermore, computer simulations for air resistance make it easier to build highly adapted airframes which reduce air resistance. On the safety side, Boom can take advantage of advanced autopilots which make it possible to fly safer. Also, the new engines which Boom already developed will run more efficient and quieter. Is this enough to bring supersonic flight to the mainstream? The aircraft currently in development by Boom will feature 50 business class seats. A ticket will be available for $5,000 a flight. This is certainly cheaper than the Concorde, but still significantly more than a conventional business class seat. Also, it cannot be ignored that a much higher percentage of operating costs for Boom comes from fuel. This means that the tickets could even get more expensive as fuel prices rise. Even conventional aircrafts could get unfeasible as oil prices rise. Either all transportation is switched to ground-based electric travel, like Hyperloop, or an alternative fuel for aircrafts gets developed. One such fuel could be hydrogen. There are two ways to use hydrogen in airplanes. It can either be burned directly in the engine, or it can be used to generate electricity. Burning the hydrogen directly in the engine is more complicated and doesn't have the benefits of the electric option. By using an electric motor to fly the aircraft, noise and pollution can be significantly reduced. Using hydrogen instead of batteries to store electricity has a few advantages and disadvantages. Batteries can be charged fast and almost no energy gets lost in the process. On the other hand, production and storing of hydrogen is difficult. Moreover, 50% of the energy gets lost by converting electricity to hydrogen and back. The advantage of hydrogen over batteries is energy density. 1 kilogram of hydrogen can be converted to much more energy than can be stored in a 1 kilogram battery. Hydrogen even has a higher energy density than kerosene. In the case of airplanes, that means less weight has to be carried, which further increases efficiency. There are some other problems with using hydrogen as a fuel alternative. For example, how to incorporate the round tanks into an airplane design, or that there currently is no infrastructure at the airports to produce or store hydrogen. Still, it comes as a surprise that nobody in the aviation industry is pursuing hydrogen as a fuel alternative. As a result, Hyperloop has a real chance of replacing regional and short international flights. Of the three technologies we discussed, Hyperloop is also the first developed. Especially if oil prices rise rapidly, a future where most people travel in capsules shooting to vacuum tubes might be closer than we imagine.